Welcome back to day 3 of our Fundamentals of Algebra unit. We're going to continue our unit on literal equations today. Today you need your composition notebook, a pencil, and a calculator. First, we're going to talk about what is a literal equation. If you were in geometry last year, which I'm hoping all of you were, you have worked with a literal equation. A literal equation is an equation with more than one variable. Some examples you might want to put down in your notes along with that definition is that if you were in chemistry, maybe you know PV equals nRT. That's the ideal gas law. Or density equals mass divided by volume. Or if you were in physics, kinetic energy is equal to 1/2 mass times velocity squared. And like I said before, if you were in geometry, you know a squared plus b squared equals c squared. That's the Pythagorean theorem. Or what about the area of a triangle? The area of a triangle is 1/2 base times height. These are all considered literal equations. They all have more than one variable. So what we're going to do today is we're going to take these literal equations and solve them for specific variables. So example number 1, circumference is equal to 2 pi r. C equals 2 pi r. How do I get r alone? That's our goal, because I want to solve for r, which means I want to get r alone. Well, before I can get r alone, we have to know what we need to do to get it alone. So let's look at this problem. C equals 2 pi r. What's happening between the 2 and the pi and the r? Well, it's not addition because I don't see it. It's not subtraction. I don't see it. It's not division. I don't see that sign. So the sign that's there, but not really there, is multiplication. So these guys are all being multiplied. Now we've learned about solving equations. When we do solve an equation, we use inverse operations. So the opposite of multiplying would be dividing. So what you do to one side when you're solving, you do to the other. We've talked about that before. So the opposite of multiplication would be to divide both sides by 2 pi. When you take 2 pi divided by 2 pi, what happens? 2 divided by 2 is 1, pi divided by pi is 1. They cancel each other out. Now you have c over 2 pi equals r. And notice we did not move the r. We circled it and we solved for r. That is the solution. Okay, example number 2. We're going to solve for y. Okay, we want to get y alone. I'm going to circle that y. First thing we want to do is we want to move the 8x. Well, what is happening with the 8x? There's actually a little plus sign out in front of the 8x. Remember when you have a plus 5, you don't have to write the plus, but there, it is being added to that side. So the opposite of adding 8x we would want to subtract 8x on both sides. Because we want to use inverse operations, we want them to cancel. And the only way we can cancel a positive 8x is if we subtract 8x. So now we have 3y equals 48 subtract 8x. Okay? Our goal is still to get that y alone. What's happening between the 3 and the y? Well, there's a multiplication sign we don't see. The opposite of multiplying is dividing. So we want to divide everything on both sides by 3. 3 divided by 3 cancels. We're left with y is equal to, 48 minus 8x divided by 3. We would say 48 divided by 3. And we would say 8x is also being divided by 3. Both of those terms are being divided by 3. Now we can simplify that and say y is equal to 48 divided by 3. With your calculator, you can type in 48 divided by 3, and you would get 16. Subtract 8x over 3. And that would be the final answer for solving for y. Okay, example number 3. Let's solve for x. Okay, we want to get x alone. Okay, but before we can get x alone, we want to not do anything with the 3/4 x. We want to get rid of everything else that's not touching the x. So this is adding b. Well, the opposite of adding b would be subtract b on both sides. So we have y subtract b equals 3/4 x. Okay, my goal is still to get x alone. Now, I need to figure out what I would do with that 3/4. 3/4 is being multiplied by x, just like we talked about in earlier slides. So the opposite of multiplying would be to divide. However, if we were to divide by 3/4 x here, we would have a fraction within a fraction, and that's complicated. So we don't ever divide by a fraction. We always multiply by the reciprocal, because 3/4 times 4/3 is 12 over 12, which is 1. So 4/3 and 3/4 cancel each other out. What we do to one side, we have to do to everything on the other. So we have to make sure that if there's more than one thing on that other side, we group it in parentheses and multiply everything by the 4/3. Now what we can do is we can use the distributive property. 4/3 times y. 4/3 y. 4/3 times negative b. Negative 4/3 b. And that equals, because the 3/4 and the 4/3 on the right-hand side canceled each other out, that leaves us with an x. And so we have solved that equation for x. Okay, example number 4. Solve for r. Okay, where's the r? Circle it. Okay, I don't want to do anything with what's on the r until I get rid of everything off the r. So I see I have a 2x over here, all by its lonesome. It's being added, and the opposite of adding, again, is subtracting. So we're going to subtract both sides by 2x. We have p minus 2x equals 2 pi r. Now again, back in that last that slide, way back in the beginning, we had 2 pi r before. And we talked about how they're all being multiplied because you don't see that sign. And the opposite of multiplying is dividing. So you're going to divide every side by 2 pi. The 2 pi's are going to cancel. You're going to be left with r equals. Again, over here, you have two terms, the p and the 2x, and they're both being divided by 2 pi. So that's really p over 2 pi. Subtract 2x over 2 pi. 2 divided by 2 cancels out, and the answer is p over 2 pi subtract x over pi equals r. That's a simplification that we have to remember, that if we have two terms being divided by being divided by 1, each one of those terms is being divided by that 2 pi. And then we can simplify from there. All right, example number 5, and this will be the last example for today. We are going to solve for a. Okay, here's our a. We're going to circle our a. Oh, we won't want to do anything with that b because it's hooked on with the b. But then we have a fraction symbol here, a division sign. We want to make sure that when we're solving an equation, we have no fractions to begin with here. we want to get rid of that 12. And so because the 12 is being divided here, we are going to do the opposite of dividing by 12, which is multiplying both sides by 12. The 12s cancel out. We now have A times B plus 8 equals 12 times C, which is 12C. Now we can look at this problem and say, okay, now I'm going to solve for A. The B is still attached, so let's get rid of the 8 first. The opposite of adding 8 would be subtracting 8 from both sides. So now I have A times B equals 12C subtract 8. Oh, still don't have A alone. So now, what is the operation that's happening between the A and the B, which is multiplication? The inverse of multiplication would be division. So we're going to divide both sides by B because we want to get A alone. Remember, we want to get A alone, so we have to divide by the B on both sides. We divide by B on the right, or excuse me, on the left, they cancel. And on the right, we get, okay, again here we got two terms being divided by B. So 12C divided by B, subtract 8 divided by B. And that would be our final answer, getting A alone and solving for A. So thank you, and we'll see you back in class tomorrow.